Well, there you go. Maybe it's time to start studying. Maybe.
What is this one? What did I do?
Prince Osai never answered me. Sad.
Do we do number 9? Did you just
What
do
did I
9
get?
too, Mel?
Yeah. What did I get wrong on 10?
Everything.
On 10? Hold on. What'd you do on 10?
You circled.
Okay, so number 9, they say. Let's look at it. Okay, yeah, sure, number 9. That's the one that's got a really ugly answer.
The other two were.
Sounds great. Well, this one may have been too, if I remember correctly on your answer, or there's a mistake in the key. Both are possible. We'll find out together right now. So we started with the natural log of x minus 2 plus 4 natural log of x plus 2 times the quantity natural log of x minus 1 minus the natural log of x. And we are expected to condense it.
Never mind, I know what I got wrong on.
You do? But I think Malcolm also asked for it, if I'm not greatly mistaken. So does Malcolm also still need it, or yeah? Okay, that's what I thought.
Still want it.
What should we do?
What I did was what I should have done.
It's distributed the 2
Distribute the 2, yes.
and stick the 4 up here. May as well, right? Sounds great.
Except I put the 4 as 4x instead of x to the 4.
Tempted to skip a step. In fact, I think I will. You shouldn't do this when you're doing your corrections, assuming you do corrections. But for the sake of time,
He's just going to put the 2
okay. Now what?
And now we make all the pluses on the top and all the minuses on the bottom.
Yes. Of x minus 2 is x to the 4th times x squared minus 2x plus 1.
So, would it be fine if
No.
we didn't?
No, because stuff reduces and cancels and does things.
So you want it to be squared?
Yeah, because stuff simplifies in a minute. It's got an ugly answer, right?
No, I was talking about.
So to finish, you'd have to distribute all the stuff, which I assume, Malcolm, you just made a mistake on somewhere.
I distributed.
Yeah, you would distribute. I suspect there's a mistake. I'll walk out enough to see if you can, to let you see if you can find your mistake. Mostly because I want to make sure there's not a mistake in the key. But let's see. So the natural log of x to the 5th minus 2x to the 4th times x squared minus 2x plus 1 over x squared.
On our corrections, do they have to be in numerical order?
Not necessarily.
I would have a problem with it being in numerical order.
Because
I haven't submitted them in numerical order.
Oh, I see.
Did you find it?
Yep.
Yeah. Because x squared in the denominator is going to eventually totally disappear because they're all going to have at least an x squared. And so you just keep on foiling it out. The x squared is going to, yeah, there's probably something small.
Yeah, I just missed a multiplication.
Right.
I just-
Yeah, on that distribution. Yeah. Yeah. All right, what else?
Should we do number 4?
Mm-hmm. Yeah, I think you like stroked out on number 4. Something. I think you must have confused yourself or something. You made some weird mistakes on number 4.
Yeah, I don't know what happened to number 4.
Yeah,
It
something
looks really weird.
Something you did strange. I don't know exactly what. I think you were in the middle of other stuff and kind of your brain went sideways. Something happened.
That was most of this test.
Well, maybe. Evaluate. Show all your work. So what should we do?
27 to the 1/3 for 3.
27 to the 1/3 for 3. I agree. Because 3 is the cube root of 27. So I'm going to turn this into the log base 27.
The thing is, I knew that, and I knew it was important, but then I didn't know how to put it there.
27 to the 1/3. Then what?
The 27 cancels out, and we get 1/3.
We get 1/3. You could add the step of pulling the 1/3 to the front, but we do have a property that just says that's 1/3. So either way would be fine. Any other questions on this test?
Keep going.
He doesn't want to do the lessons.
Well, we're not going to do we're not going to do a ton of time here at this point. Number 7, he says. Okay.
I did that one. I thought I got that one right, but I was wrong, and I was sad.
What happens when you just rely on your calculator?
I don't think I might have.
I don't remember.
I don't know.
I don't remember this problem.
That was a while ago.
Like, I thought I did the same thing on number 6 as I did on number 7, but I got number 6 right and I got number 7 wrong.
What numbers?
7, 6, and 7. No.
I made one of the best math jokes I've ever made last period. It was very fun. I was talking about that later we're going to do rational expressions, and we're going to murder the x's, and we're going to make them cancel out, whatever else. And one of the girls was like, teacher teaches students how to put a hit on students. And then I was looking at the problem, and a great joke came to me. And I said, teacher teaches students how to hit on x's, on their x, which I think is really great and wonderful. I need that one on a t-shirt. That one is t-shirt worthy.
Did the class get it?
Yeah, they got it. They thought it was hilarious. I thought it was hilarious. Algebra 2. Okie smoky dokie, what should we do?
Number 2 is hard. Not this hard, though.
Okay, what should we do? Figure out what the graph looks like.
Yeah. Yeah, what does it look like? What does it do?
It's like a...
It goes to the left 3, no, to the right 3.
No, it doesn't do that.
Should it not? No, it goes to the right 2.
It doesn't do that either.
It gets compressed -2 times.
It doesn't do that either.
How does it go to the right 2?
I swear it goes either to the right 2 or the
It
right
gets
2.
reflected.
It gets reflected is one of the things. That's true.
The -2 pushed it
What else does it do?
vertically stretched.
Vertically stretch, and what else?
Vertically moved.
Moved down 3. So it stretches by 2, moves down 3, and is reflected. And then when you do the points, it's going to look something like this.
Yeah.
With your axes drawn on there nice and pretty so we can see what the heck is happening.
That's what I drew.
It's not what you drew.
What did Malcolm draw?
It is kind of what we drew.
What?
Swear we all drew the
What did
exact same
Malcolm
thing.
draw? Can I see what you drew? And Malcolm got it. I swear. Is that Lonnie axis?
Look at your asymptote,
I
Reese.
have it
I
at
can.
3.
That's true. That's
So I
not.
had the right shape, I just had it in the wrong place.
Yeah.
Okay.
I guess
It didn't shift. It didn't shift left or right. Which so I will like encourage you that you were thinking here. You were just didn't study that part and you were thinking it in the wrong direction.
Me and Reese did the exact same.
So you were thinking more than just trusting your calculator, which I approve of. You just were thinking in that 3 moved in the wrong direction. Because outside is vertical. Inside the parentheses. So if there were parentheses here, then it would be right 3.
I think I asked, so the parentheses are around the x, not around the x minus 3? Yeah, I think I
Yeah.
asked about
Yeah, if there's not parentheses, then there's not parentheses. We definitely talked through that one.
Yeah,
That was definitely asked and answered.
Is the negative 3 in the...
Yeah, definitely.
And you said it was out. So
Definitely. Any other quick questions before we start doing trig functions?
10. Apparently I got 10 entirely wrong.
I don't know if you got 10. How many points did you get off of it?
7.
4.
It's worth 9, so something happened.
Let's go. I don't know. I did stuff.
I got x equals 1, too.
It's not the answer. It's how you get to the answer.
Answer is x equals 12.
It looked so pretty whenever I did it. I was like, there's no way this one's wrong. It answered, it was so pretty.
So could we not kill
Did you get
log
12?
base 7?
I only got minus 7.
He only got minus
I don't like Malcolm.
He only got minus what?
1. Because I forgot to put that f of x.
See, the thing that you should understand about Malcolm that sometimes I think you forget is twofold. Malcolm is analytical by nature. His brain works that way. He's good at it naturally. And he studies. He does both of those. He does both of those things. You have started studying more, which is true. And so here's the thing. The thing is, this is the hardest class I teach by a wide margin. And your grades are still like at least close to what you're normally making, right? So you could probably do more than you're doing, but you're doing fairly well.
Okay.
You slacked off for a long time and you're still keeping up, which is good.
Yeah.
That's good, right? We like maturity, right? We like gaining maturity. Okay. What should we do now? You can't just kill the logs yet.
We can't.
No,
What I did first.
because of that plus.
Yeah, combine them.
Because of that plus, you gotta stick these together first. Which property is that?
It's where they multiply.
Yeah, product property. Great. So, skipping a step, 6x equals 9x minus 36.
That's where I messed up. I forgot to distribute the 9 on.
Yeah.
Ruined my whole answer. Gave me no solution.
And then y'all can solve that.
That's simple.
That's easy. Let's learn some trig functions, shall we? You can have it, since I got to get my book anyway. Otherwise, the answer would be nah.
I got x equals 12. So we're
Wow.
still do simple math.
You
It's like on that one,
Oh.
Alright, so now I've got to fix this one, and then my corrections are done.
I mean, during algebra 1, I did
I want
0
that
going
one.
back never. I hit it better than Jeremiah did, though.
Yeah, but he made better grades than you did by the time Algebra 2 happened. So, you know.
Well, you see, if it was x
It's
minus
always the
4
old Jeremiah.
then it would be no.
That's true, but that's not what it was. That's not what had happened.
And so I failed that question and got the most.
No, right?
Well, not 5-1. That's sad. Chapter 5 is a lot better than Chapter 4, but we got to do Chapter 4 first.
I don't like chapter 4 or chapter 5.
I absolutely love chapter 5. It is far and away my favorite in this book.
Will I like it, or will I hate it?
Heck if I know.
You generally know my math stuff things.
I know that you whine a lot.
Yeah, you do.
All right, so we're going to start with review. We're learning about trigonometry. We're going to spend 2 units on trigonometry. We're going to learn about trig functions. We're going to learn all of that in this unit, and then in unit 5, we're going to learn about trig identities, and we're going to do a bunch of trig proofs, and it's going to be a lot of fun. But the first thing we are going to learn is review. Trigonometry, it is 4-1. Right triangle trigonometry.
He wants my paper. My paper's better. I already gave you one.
Okay.
Okay.
Right triangles have 3 sides. Whoa. I know, it's astonishing.
Right
It's
triangles.
astonishing.
It's because they're so pretty.
I just love right angles.
Everybody does.
Sean taught me to love right angles.
Okay.
4-1.
We often use the Greek letter theta to represent an angle. We also, if we have a couple angles, we will often use alpha, but sometimes you can see beta or other things. You could just see an X or whatever else, but those are what we typically use. If we're looking at the Greek letter alpha angle, this one right here, he has 3 relationships. He has an opposite side. He has an adjacent side. Bless you. And he has a hypotenuse. How can we tell which is which?
The longest one is the hypotenuse.
The longest one is the hypotenuse. It's also the one that's across from the 90-degree angle. Both of those things are true, right? So how can we tell the other ones?
It's based on which angle we're using.
Yeah, that angle. How can I tell which one's which?
The adjacent is directly the line.
Adjacent is adjacent to it. Whoa.
And the opposite
Is opposite it. Yeah, great. Easy peasy. We got the easy stuff easy, right? So there are 3 relationships, 3 ratios. They are trig ratios. We can remember it with the kind of native sounding not word, but why not? SOHCAHTOA.
Oh yeah, I remember this.
And the more you actually pronounce it phonetically and not with some weird accent, the more it'll actually be useful to you. SOHCAHTOA. Ah with an A, right? O with an OH, and then OA, right? Right? S stands for sine.
Yeah.
I said this one was review, so I'm glad that you remember something.
Cosine.
C stands for cosine.
I still can't spell sine.
T stands for tangent.
Is it not just S-I-N-E?
I spell it S-I-G-N.
How do you spell
That's a totally different word.
actually spelled tangent?
O stands for opposite. Wow.
Op. It's the ops.
H stands for hypotenuse. A stands for adjacent. Yeah.
Hypot.
Have ops, height, and edge.
I wish I was high on hypotenuse.
Wow. Wow, wow, wow. We're gonna cover a lot of this lesson not all the unit, because once we get past the first lesson or two, it's not review anymore. But the first lesson or two is very review, so we're going to cover it pretty quickly. So those are the 3 main trig functions: the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse, and the tangent of theta is opposite over adjacent. So we're going to learn what identities mean in the next chapter, but we're going to learn a couple of identities now. We're going to use them real basically in this chapter, but later we'll learn more. So the first three identities we're going to learn are the reciprocal identities. This is really, if I'm not greatly mistaken, the first new thing that we've covered. We don't cover reciprocal identities in geometry. Okay? So the reciprocal identities are the reciprocals of the main ones. Okay. And the way you rememberize them is S to C, C to S. Easy peasy. Okay? So the cosecant. Cosecant, that's what the heck that word is.
What does the word mean?
Cosecant, which is abbreviated CSC, of theta is 1 over the sine of theta. So that would be the hypotenuse over the opposite. Right? Easy peasy.
So is this sine -1?
That's different. There, you probably don't have a secant or cosecant button on your calculator. You might in like the menu or something, like in the math menu or whatever, maybe. But if you were going to punch it in the calculator, you would just do 1 divided by sine. Yeah. That would be the fastest, easiest. Okay, so cosecant is the reciprocal of sine. Secant, which is abbreviated SEC, of theta is 1 over cosine. We'll see S to C, C to S, right? That's how you can rememberize it. So that would be the hypotenuse over the adjacent. The reciprocal of tangent is really easy. We don't need anything fancy to really remember it because it's super easy because it's just cotangent. And it's abbreviated COT. Cotangent of theta is 1 over tangent theta. And so it is the adjacent over the opposite. Now, there is one more identity that we go ahead and learn now. We're going to learn a bunch of identities in the next unit. But, but there's one more that can be useful. And that is that tangent is sine over cosine. So cotangent would be cosine over sine, right? Easy peasy so far?
Can we do an example of something?
Yeah, we're going to do an example.
Okay.
Let me teach. That's you, student. We're good, bro.
What did you write?
Tangent is sine over cosine.
And then cotangent is cosine.
Yeah, because it's a reciprocal.
Oh yeah, I forgot about that word.
Reciprocal?
Yeah.
Well, welcome back.
Welcome back to geometry.
I'm pretty sure that was more like pre-algebra.
Yeah.
Pre-geometry. Pre-geometry.
Okay. Let's do an example. Let's do guided practice 1B on page 221.
220 what?
We're doing guided practice B.
1B. Okay. So it says find the exact values of all 6 trig functions. So the sine of theta would be what on this one?
I gotta pull out my calculator.
You don't need your calculator. Put it down.
Oh,
This would literally be on a no calculator portion of the test, bro.
no, okay, fine. I just didn't want to have to do the actual dividing.
You don't have to do any dividing, bro.
Oh, you want it as a fraction?
Yeah.
Okay. So that makes.
Okay, good. So now that we've cleared that up, what is the answer?
21 over
29
29.
29ths. Easy money. What's the cosine of theta?
Cosine.
20 over 29.
20 29ths. What's the tangent of theta?
21 over 20.
21 20ths, I don't know what to say, etc. Right? That's easy money. You can finish that one out on your own, no problemo. Let's do another one. Let's do guided practice 2. This one's got a little bit more involved. Okay, so guided practice 2 says, if the tangent of theta is 1/2, find the exact values of the 5 remaining trig functions for the acute angle theta. That's important because depending on what they are, you can get 2 triangles with a couple angles the same. All right, so we got an acute right triangle.
That's a cute little triangle. If it's a right triangle, doesn't have to, don't the other angles have to be acute?
Yes. But we're going to get to some stuff where we're going to find angles that are like over here and whatever else later. But okay, so it says that the tangent of theta is 1/2. So where does the 1 and the 2 go?
1 goes on the left side, 2 goes on the bottom.
Great. So how can we find out the third one? Pythagorean theorem, that's right.
1 squared plus 2 squared is
1 squared plus 2 squared equals c squared.
Yeah.
1 plus 4 equals c squared, so c equals the square root of 5. I know it's technically plus or minus, but right, we're talking about distance, yes? So square root of 5. So what is the sine of theta?
square root of fifths. I don't know how to say that. 1 over the square root of 5. Is there?
It's 1 over.
Or 5 over the square root of 5. Oh.
Okay, so let me walk out what we did. I skipped like all kinds of steps. So it is 1 over square root of 5. That's ugly. We don't like that, so we got to fix it, right? We have to rationalize it. How do we do that? Square root of 5 over square root of 5.
And it becomes 5 on the bottom.
Get the more you get used to being able to do, and we, if this was algebra 2 or before, we would like walk it out every single time. The more in this unit especially, and the next one too, the more you can get used to kind of rationalizing something, like just doing that in your head. Like I would actually encourage you to practice that. You don't have to. Like if you write this if this is in your margin every time, great, it's fine. I will not think any bad about you, but you're going to do this a lot, and so I would practice doing this in your brain, right? So the cosine of theta would be 2 over the square root of 5. So what would that be rationalized? 2 times the square root of 5 over 5. Now, if that 2 was, say, a 10 or something, you may want to jot down in the margin, oh yeah, that, and then reduce, right? So you want to, or watch for being able to reduce stuff, right? So that's worth saying. Then the tangent we already know. And then the reciprocal functions are real easy on these because we don't even have to do it, right? It's just that original thing flipped over. So would be square root of 5 over 2, right?
Yeah.
And the cosecant would be just square root of 5.
And then cotangent would be
5 halves, right? No, it would be 2. You're right. No, cotangent would be, no. I was right to begin with.
Wait, why are did it ask you to find the secant or something?
Oh no, the cotangent, yeah. No, I'm doing the tangent in my head. And I'm doing it wrong, but it's fine.
Yeah, cotangent would be 2.
Yeah. Makes sense. Any questions on this problem?
Wait, why did we find specifically the secant of it?
It asks for all of them. We'd keep going. We'd do the cosecant. The cosecant of theta, which would be square root of 5. And then the cotangent, which would be 2, once we find it all out. It asks for all of them. Yeah.
We just didn't finish it. What about the tangent?
It gives us tangent.
It does?
Yeah, that's the whole, that's the start. Yeah, that's the beginning of the problem. Okay. All right, let's do a problem that's easy. It's like something we would have done last year.
I like easy things.
This one you would just shove in your calculator. This one you would just shove in your calculator.
I love doing that. I love shoving things down the
No, we're not going to do that yet. We're going to come back and grab that.
Yeah, I think that's something wrong about
But we're going to. It's very strange that they shove that in and then don't do anything with it. We'll do something with it in a minute. Okay, so let's do guided practice 3B on the next page. So we've got this triangle. Isn't he cute?
Very cute.
21 degrees. We've got an X over here, and there's a 9, I think. Is that a 9? And we're asked to find X. So what should we do?
We should do
Which trig function are we using?
Tangent, but we got
Tangent, because we've got opposite and adjacent, right? So the tangent of 21 degrees. Now, in geometry, we just made sure we were in degrees and we were off to the races. We're going to learn about radians soon and very soon. So you need to always, on whatever problem you're punching in, make sure you're in the right thing. So you need to know how to switch between degree mode and radian mode on the calculator. So if you don't know how to do that, figure it out now. If you need help figuring it out, let me know, and I bet I can figure it out.
I've always wondered what radians are. I can't wait to look at it. Wait, do I do that now? I guess.
Hi, how are you? Welcome to high school pre-calculus. All right, y'all figure it out? You're,
There's degree mode, there's radian mode. Figured it out. I'm in radian mode now.
it's not there. It's
Then what if I change to a degree?
these noises.
Now I'm gonna change it back to radian.
it's got to be simple. Is it in setup? Probably, yeah, setup. Yeah. Okay, so it's in setup. So shift and Blapio, and you are currently in radians. You need to. Oops.
Do we need to be in degrees or radian?
Well, this says 21 degrees. So what you think?
So let's do degrees.
And then we probably push some. Oh, look, it's right there on the menu.
What's
So
the difference in them? Isn't like the
we will discuss that. Not at the moment, but great. Now you're in degree mode.
get it?
Great.
Get it?
Did you find it, Malcolm?
Yeah. Oh yeah. It's under.
Oh, yeah.
I already knew where. Oh yeah.
Oh yeah, easy money. Okay, so the tangent of 21 degrees equals 9 over x. Multiply x on both sides, and we end up with x times the tangent of 21 degrees equals 9. Then divide. X equals 9 over the tangent of 21 degrees. If the instructions said leave your number in exact terms, we would circle that and move on with our life. But what the instructions do say is round to the nearest degree if necessary. So we're going to make sure we're in degree mode and shove that in our calculator. We're going to get x is approximately equal to, it says to round to the nearest degree. So try again. Actually, it doesn't even say round to the nearest degree. I was looking at the wrong problem. Just kidding. That's not a degree. How about round to the nearest tenth?
23.5.
4.
4. 4. You looked at the wrong person.
Bam. Easy money, right?
That's fine.
Okay, so another bit of stuff that will show up on the no calculator portion
Oh, no.
is needing to know about exact, what am I saying? Needing to know about special angles is the word that's trying to come to my mouth. Okay? They are special. This is also review.
How special are they?
They're quite special. Okay? So one of the special triangles is the 45, 45, 90. Special for obvious reasons, right?
Because it's exciting.
Because it's isosceles, right?
And it's why'd you write a?
Okay? So 45, 45, 90 degrees is our first special right triangle.
Is it like 1, 3 square root of 2?
Okay? So with this one, in order to get the ratios, if we make this side 1, this side would also be 1 because it's isosceles, right? Base angles are congruent, therefore it's isosceles. So if we use Pythagorean theorem, we get square root of 2. Right? So the sine of 45 degrees is square root of 2 over 2. The cosine of 45 degrees is square root of 2 over 2. The tangent of 45 degrees is 1. I'm going to put all this in a table in a minute because I think it's easier to memorize the special angles using, I think it's easiest with the table because everybody in here can count to 4. So. I know, you can. It's great. I bet even our people on the internet can count to 4. Okay? Yeah. Right? So that's why we're going to form it in a table here in a second. All right, so the other special right triangle is a 30, 60, 90 triangle. If you'll remember from geometry, the reason why a 30, 60, 90 is special is because it's derived from an equilateral triangle, a 60, 60, 60, right? That's where we get the 30, 60, 90. We chop it in half in order to make it a right triangle, and we get a 30, 60, 90, right? Now, if we have our big equilateral triangles, we could do like sides of 1, 1, and 1, but then when we split it in half, we've got a half, and so that's ugly. So if we make this side 2 instead, then the little leg that's cut in half would be just 1. And then we use Pythagorean theorem and we get the square root of 3.
Hold up, wait a minute.
So the sine of 30 degrees is 1/2. The sine of 60 degrees is square root of 3 over 2, et cetera, et cetera, et cetera, right? We could find all that stuff. So let's build us a little table. I like to build the big one at the beginning instead of building 12 tables. Okay? And we're going to add a couple other things that we'll actually get, and we'll concrete it even better from unit circle here in a bit. But, and by here in a bit, I probably mean next class, but that's fine. All right. So we've got in our table, we have the sine of theta, the cosine of theta, which, to be clear, we're going to add a bunch of stuff into this chart. These two are the only ones you have to memorize. Because if you know these two, you can get all of the rest of the table using those identities that I showed you. Yeah. So if you memorize sine and cosine, which you can memorize by counting to 4, you're off to the races.
1, 2, 3.
No. 0, 1, 2, 3.
0.
Okay. Tangent of theta would be what we're going to put next. And then we're going to go ahead and have all our reciprocal ones in this table in this part of our notes. The secant of theta, the cosecant of theta, and the cotangent of theta. Now, I'm going to leave a little bit of space, and you'll see why I'm going to leave a column right here in a minute. But up here at the top, I'm going to skip a column, and I'm going to write 30 degrees. And then the next smallest special angle is 45 degrees. And then 60 degrees. And then I've got an extra column here, and I've got an extra column at the end as well. What I'm going to have this column be is 0 degrees. Which we'll cover 0 and 90 degrees in more depth in the next lesson we talk about unit circle. What is happening? Oh.
Yeah.
Don't tear stuff up if possible.
Yeah, we figured it out.
Okay.
How do you have it with 90 degrees if the opposite is the hypotenuse?
Like I said, we're going to talk about those when we talk about unit circle because it'll make more sense and it'll be easier to understand then. That's why we'll cover that in more depth there. We're just going to say this is what it is and it'll make sense when we talk about unit circle. Okay, so sine of 30 degrees is 1/2. Wow. What is the sine of 45 degrees? Square root of 2 over 2.
Yeah. Square root of 2 over 2.
What's the sine of 60 degrees? Square root of 3 over 2. The sine of 0 is 0 degrees is 0. The sine of 90 is 1, which is the same as the square root of 4 over 2 if you want to think about that in our countings. So sine is 0, 1, 2, 3, 4. Cosine's the other way around. Cosine of 0 is square root of 4 over 2, which is 1. So cosine of 0 is 1. Cosine of 30 degrees is the square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Square root of 60 is 1/2. And square root of 90, not square root, cosine of 90 is 0.
So you don't even have to memorize both of them. You just memorize one of them, and then you go.
And remember the other one's going the other way. True enough.
I'm just
True.
gonna.
Well, yeah, you can literally.
But you got to take a mental picture because this is something that you have to have memorized and will not be on any kind of chart.
Yeah, you just got to remember sine and then reverse it and you get cosine.
Yeah. So if you remember that tangent is sine over cosine, then you can pull it from these. What's 0 over 1? 0.
That's
Great.
way too long.
Well, because I was going to say undefined and that's 1.
Now we're getting there.
That's for 9.
And then what's 1/2 divided by the square root of 3 over 2?
2 times fraction, which is 2 is the square root of 3 over 2. What?
1/2 times 2 over square root of 3 is 1 over the square root of 3, which is square root of 3 over 3. When you divide fractions, you multiply by the reciprocal.
I was thinking the other way.
Yeah, I was so confused.
I was thinking the 2 over, or the square root of 3 over 2 is on top.
Yeah, okay.
I get it now.
Okay.
This one is going to be the one that y'all's brains are trying to do.
Yes, that's what I was trying to do a second ago.
What's square root of 2 over 2 over the square root of 2 over 2? 1.
1. Yeah, okay.
That also took too long.
So, yes, that's what I was trying to get, but it doesn't work.
Oh, there's Reese's best friend, undefined.
Yeah, I tried to do that on 2 different, I did the wrong one on 2 different things.
And secant is just 1 over cosine. What's 1 over 1?
1.
1. What's 1 over square root of 3 over 2?
Square root of 3, no, it's 6, no, 2 times the square root of, 2 times the square root of 3 over 3.
We had to just flip it over, 2 over square root of 3, and then 2 times the square root of 3 over 3. You don't have to be able to do that in all that in your brain.
I will not be.
That's fine. And then 1 over square root of 2 over 2.
Is 2 times the square root of 2 over 2.
Which is?
Square root of 2.
Thank you. And then 1 over 1/2 is what?
2 times the square root of 3 over 3.
1 divided by 1/2 is what?
1
One divided by 1/2.
I got confused how we got there. Shouldn't we be
No.
square root of 3 over 2? Because we're doing
1 over cosine. Secant is 1 over cosine. That's how it's defined. S to C, C to S.
I've been doing the wrong thing this whole time.
I think you just started doing it. Is 2. Did you put that in your calculator?
Maybe. There's a small
You
chance
multiply by the reciprocal. 1 times 2 is 2.
There's a small chance I put that in my calculator.
What's 1 over 0?
Undefined.
Undefined. Cosecant is 1 over sine. What's 1 over 0?
Undefined.
Secant and cosecant are just the same thing, phase shifted. So are sine and cosine, but that'll make more sense once we get to the graphs. Anyway, what is 1 over 1/2?
2.
2. What is 1 over the square root of 2 over 2?
Square root of 2.
2.
Two square root of 3, 3.
What is 1 over square root of 3 over 2?
2 square root of 3 over 3. 1.
What's 1 over 1?
I definitely just did all that. I did just like, one in my head. It's great.
Now do cotangent.
No. Make me.
It's undefined. He's speedrunning it. Man.
Now let me take a picture. I want to take a picture. I'll pick a picture.
He don't want you to take
No, I'd rather y'all, take notes like you're supposed to. That'd be great. I'm not going fast.
Was it 3 times?
Most of the table is in the book.
Yeah. Where?
You can't pause real life.
You can pause the video.
That's true. That's true. And if you want to go back to the video and pause it and take a picture of it, I promise you won't learn it as well. But I cannot stop you from doing that. I am not going to your house and taking away your whatever device you're watching the video on.
Or we could just look at the book and know
Great.
that the only thing it's missing is 1s and 0s and undefined.
True enough. True enough. It's missing the 0 and the 9, which it probably has a table of that in the next lesson, I bet, because it's talking about unit circle. So it probably has those, just a few pages is away. Okay, so you asked about this button on your calculator, which was a great thing to ask about. This has another name, which I like better, even though it's older, it's antiquated. People don't use this notation anymore, although there's a few calculators that do. I think my HP might, I don't remember. This used to be called something else. It is called the inverse of sine. I don't like this notation because this does not mean this. That's not what this means. However, and that'd be fine, however, this does mean this. So I don't like this notation, but it is the normal notation now. You just need to know by context that they don't mean the same thing. If we're trying to write this, what we would write is this. Right? Because that's the reciprocal of this. So context, we know what's happening. Okay. Now, so what is this? What does this mean? So the old notation you might see sometimes in books or whatever else, and there are a few calculators that still use this notation. Oh my gosh, you're spamming something. Are you about to get kicked out? Oh, you kicked yourself out. Oh, it's just you just said hi. Hi. Okay. Goodbye, apparently, because it doesn't seem like you're here anymore. Anyway, what this used to be written as is arc sine, which I like better, but I will be using this notation because it's the norm now. And what it means is that the arc sine of the ratio is the angle. Okay? That's what it means. Let's do an example to figure out kind of what we're talking about.
This is what you use whenever you got
Yes.
the thingy, and then you want to
Yes, if you're yes. All of that is correct. If you're given the sides and you're trying to find the angle, then you use the inverse trig functions. Okay? So something like this. Right? This guy. And if we have theta right here, we have a 5 right here and a 12 right here. And we are asked to use the trig function to find the approximate measure of theta and round to the nearest degree if necessary. So, what trig function are we looking at?
This is
Adjacent hypotenuse, so it's cosine. So the inverse cosine of 5/12 equals the angle. And then you shove that in your calculator and push enter. Make sure you're in degree mode if we're looking for degrees, which we are until we get to, what is it, lesson 3? Or is it the next lesson? Oh, no, just kidding. It's the next lesson. And then we get to learn about radians, which are far superior to degrees for math. What? Why? I'll show you, but it's mostly because denominators.
Why is my mom?
You can, you,
She knows I'm in math class.
what is the answer, approximately, to the nearest degree?
65.
Great. Easy peasy?
What?
Let's do an angle of elevation problem. Time is it? Ugh. I wanted to go through this fast, and we are, but we're not going to get quite as fast as I wanted to get. We are going to finish this lesson, but we're not going to get any further than that, which is fine. That's how pre-cal goes. There's just a lot in each lesson. All right, we are going to do guided practice 6 at the bottom of page 224, camping. A group of hikers on a camping trip climb to the top of a 1,500-foot mountain. When the hikers look down at an angle of depression of 36 degrees, they can see the campsite in the distance. What is the horizontal distance between the campsite and the group to the nearest foot? This problem is the type of problem that highlights the practicality of trig. Of any math that is being used, I know this particular example, like this is like hikers at a mountain, like who the heck cares, but of any just kind of like high school math that is done, trig is one that gets used in the real world all the time. Those guys over there, the people that went and did surveys used trig. They literally did. When you see those guys setting up with their tripods and their angle finders and that stuff, that's what they're doing. They're figuring out these angles and whatever, figuring out the angles to build houses, all this stuff, right? And all the things, yeah. So anyway, problems like this. All right, so we got to do the thing. I'm gonna sketch out the problem a little bit. We got our little hikers on top of a mountain. Aren't they cute? They are looking down at 36 degrees.
How do they know that they're looking down at 36 degrees?
Well, actually, there's a super easy thing that you could make today that would be able to figure that out. You just stick a straw on a protractor with a washer and a string hanging down from it, and you look down and capture the string, and then it's 36 degrees. Hey, you could make the device that can tell you that.
Oh, that thing was also called something.
It is called something. Okay. So they also knew, because they were good little trail life boys, and they knew that they were up 1,500 feet. And they would like to know, how far away is the campsite? Right? Makes sense? So, how could they do that?
They could use tangent along with what, 1,536.
Oh shoot, we know what that angle is. Oh man, I forgot about this stuff. 36, and then you get 4.
You're doing too much. You're doing too much. It's alternate interior angles. No, you're doing too much. It's alternate interior angles.
Oh, wait.
44.
It's congruent.
I am looking at the wrong angle. That's why none of
Oh,
this
I was
is
looking
making
at the
sense.
angle next.
Yes, I was thinking that was inside. Okay, that's
Great.
Oh, and then the other one's 54.
You just need the compliment.
We don't need any of that.
Yeah, but I like it. That makes me happy.
All right, tangent of 36 equals 1500 over x, and then solve. Easy money, yeah? Let's give you some homework and then kick you out, right? Yes. I am right.
Okay.
What is today? Tuesday?
Let's take guesses, guys. I'm guessing 2 through 36.
Oh, yeah, that's got that problem. I think that's probably good enough.
We're
Yeah?
posting 26. I bet it's 36.
Yeah, I think that's good. Or do we want to grab that too?
Was the answer to the problem 1089?
2065.
2090, I guess. Wow, what did I do wrong? Oh, I used 36, that's why.
Remember Taylor from
Oh, and you were doing
every time
it the other way around?
Yes.
No, I think, because most of those are fast anyway. Yeah. Homework, pages
Pages.
227 through 228, numbers 2 through 42 evens.
That's not much. That's only 20 problems.
Ready, go. And by go, I mean, get out of here. Go find somebody that loves you. Give them a high five and a fist bump.
And call my mom back. She's been calling me like 4 times during math class. She's probably angry at me for no reason.
Hey, do you want my test with my test?
Yes, always.
No. I'll either give it to you on Thursday or next Tuesday.
That's fine.